For this example, it says use the Pythagorean identities to find sine of t for the given value of cosine of t, and make sure that the sign is correct for the given quadrant. Here's the example. Here are my Pythagorean identities. We have 3, and we're going to use these to find sine of t. Now, this looks a lot like a previous video I made, except that they would give me one function and we had to find the remaining 5 functions. In this case, they're only asking us to find sine of t, not the remaining 5 functions. So this is much shorter. And they're giving us cosine. So let's go ahead, and I want to apologize if you hear any background noise. Those are the cars passing by. I'm not recording where I usually record, which is in a back room I have very far away from the street noise. So if you hear that, please, I apologize. Okay, so I have cosine, I want to find sine. And before we start doing that, I want you to pay close attention to this here. It says that the angle that we're talking about, this angle, is found in between pi and pi halves. So let's draw our coordinate system here. And this is where pi is, and this is where pi halves is. So my angle is in between these two angles. That means that this angle is in quadrant 2. This is quadrant 2. Now, why is this important? This is important because depending on what quadrant I'm on is the negative or positive sign that I will have on my function. So for example, in quadrant 2 here, the sign for cosine, which is my x-coordinate, is going to be negative. But the sign for my sine function is going to be positive. Now, where else on this coordinate plane is cosine negative? Well, in quadrant 3, my cosine will also be negative. So that's why they have to tell me where specifically am I standing. Am I standing in quadrant 2 or quadrant 3? And depending on the quadrant I'm on, that's the sign I'm going to use for sine function. And here's a really noisy car. Oh, I'm going to have to listen back to this recording. If it's too noisy, then I'll have to record it again. Okay, so we're on quadrant 2. That means that my cosine is negative and my sine function will be positive. So when I find my sine function here, it'll have to be positive. Okay, so how do we find it? I have cosine. Here, out of these 3 identities, I can use this one to find sine. So let me write it here. I have cosine squared of t plus sine squared of t equal 1. I know what cosine is. They tell me right here. So all I'm going to do is I'm going to write 3 over the square root of 10, and I'm going to square that because it's cosine squared, plus the sine squared of t equal 1. And now I am going to solve, and I'm going to have that negative 3 squared is positive 9, and square root of 10 squared is 10, plus sine squared of t equal to 1. Now I am going to solve for sine squared of t. So sine squared of t is equal to 1 minus 9 over 10. All I did was subtract 9 over 10 on each side. And now I can say that sine squared of t is equal to 10 over 10, which is 1, minus 9 over 10, and that equals 1 over 10. That's a sine squared of t. But I don't want sine squared of t. I want sine of t. So that means I have to take the square root on both sides. And when I take square root, I'll have the positive and the negative values. But since I know I'm in quadrant 2, this would be plus minus. Since I know I'm in quadrant 2, I know that the sine function has to have a positive sign. So I will use only the positive. Okay? And here's sine of t. And I know that we have taught you since Algebra 2, Algebra 1. We have said that we don't want any radicals in the denominator. Your book, the book we're using in class, they will allow this on some of the functions, and this is one of the examples where they keep the radical in the denominator. But you can certainly go ahead and rationalize this by multiplying, and then you will have square root of 10 over 10. These values are equivalent, okay? And that's it. That's all you have to do for this example. I hope you understood it. Try it yourself. Go back and try this on your own and see if you get the same answer. I'll see you in the next video.